How's it going, everybody? Let me go ahead and get the microphone over here. Hey Devs is here, and we're back with some more LeetCode. If you haven't followed along with the last episodes, we have been following along LeetCode's roadmap because it's a very laid out structure. It's easy to follow, and it teaches you concepts you need to know as you go along, right? So we have completed contains duplicate, valid anagram, to-sum, and let me go to group anagrams. I completed group anagrams, but the video was very long and my explanations weren't very good, so I went ahead and scrapped that, and we did a part of the solutions tab. Oh, this is LeetCode's, obviously. But I'm gonna go to problem list. Yeah, I think this is it. Remove duplicates from sorted array. So we completed number 26, and then we completed the to-sum problem. Yeah, so that's 4 LeetCode problems in 2 days, and the third day, even though we completed the group anagrams one, it wasn't a good solution. So this time we're going to do another medium problem. I wanted to challenge myself, so I didn't want to redo one I already did. I might redo this one tomorrow because I have work all day. But the top K frequency, I took a look at it, and I tried to make sure I understood the problem and knew how to solve it before I tried to explain what I'm doing in the video, of course. So 347 top K frequency elements. This is probably the only LeetCode problem I do in today's video. But given an integer array nums and an integer k, return the k most frequent elements. So if they pass us an array of numbers and they pass us a value of 3, they want us to return the 3 most frequent values in that array. So in this one, it has 1, 1, 1, 2, 2, and 3. It's asking us to return the 2 most frequent values, and that would be 1 and 2, of course. And this one is only asking for 1, so there's 1 in there. And this one's asking for 2 again, and then there's 1, 2, and 3. Num's length can be anywhere from 1 to, what is that? Is that 10,000? And then numbers can be anywhere from it can be 100,000 from 1 to 100,000, and then num's I can be anywhere from, I think that's negative 10,000 to positive 10,000. Okay, is the range of 1. It is guaranteed that the answer is unique. So I think that's what they're meaning by that, is there's not going to be an array of just 1, 2, 3, 4, 5, 6, 7, and we have to find the most frequent one when there's equally as frequent. And then follow up, your algorithm's time complexity must be better than the log n times log n, where n is the array size. So my original solution was to create a map, of course, of integers. Okay, and the first integer would be the values themselves. So we would want to get like an array of like 1, 2, 3, 4. We would want to have the map, or we can go ahead and write down the first example. So an array of like 1, 1, 1, 2, 2, 3. We want our map to kind of look like 1 is equal to 2, or 3, 2 is equal to 2, and then 3 is equal to 1. So the first value would be the actual value inside the array, so 1 is the key, right? And then 3 would be how many times 1 has been entered into the array. So we can see there's 3 1s, so 1 is equal to 3 times. And then 2 is 2, and then 2 is equal to 2 times. I feel like that would be the simplest way to map the values and keep up with the frequency. So we're going to call this frequency map. And this is going to be equal to new map. Then we're just going to do a hash map. And then integer. And I know in the newer Java versions you don't have to specify the type of the hash map if it infers it from the left, but I just always do it because my professor would get onto us for that. He didn't get onto us, but he strongly encouraged it so you would know what's happening. Because later on you might set frequency map equal to something, and then you want to know what it is, you know. So it's always good when you use new to go ahead and specify the template variables. So we want to go ahead and get our frequency map filled up. So we want to do for num, int num, in nums. We want to check for each num if the frequency map contains the num, not contains the key, because each number is the key itself. Num. And if it contains the key, we want to get an int value. So we want to get the value from the map, from the key. So we can do frequency map dot get value, or just get, not get value. No. And that will return the value itself. And then once we get the value, we want to increment it and put it back into the map. Dot put num, and num's the key. And since every time you put something into a map that's already there, it will just replace the value itself. It won't add a new. You can imagine the keys as a set, and then the numbers as just linked to the key almost. So there's no repeat numbers, but there can be repeat. There's no repeat keys, but there can be repeat values, of course. And be careful. My original solution when I was typing this up, I did values plus plus. What this does is it will put numbers and values into the function, and then it will increment value, aka not incrementing value at all. So we want to put plus plus at the beginning to be sure to increment value before we insert it into the function put. All right, and then else, if it's not a key, we want to make it a key and set the initial value to 1. All right, so we can do frequency map dot put num and 1. So this should go ahead and link all our values, and we can go ahead and do, we want to return null so the compiler doesn't scream at us, and then we can do a sysout. System.out.print line frequency map. If we hit run, we got it wrong because we didn't return the right value, but you can see, like I was saying, we want 1 to be equal to free 3, because that's how many times 1 is in there, and then 2 is equal to its frequency, so 2 is equal to 2, and 3 is also mapped to its frequency, so 3 is equal to 1. And then we see the other cases, so case 2, 1 is equal to its frequency, or mapped to its frequency, I guess you would say. And then in this one, you can see that 1's frequency is 4, and then 2's frequency is 4, and then 3's frequency is 2. So that gets that out of the way. And the next thing we want to do is we want to sort the map by the values itself, right? So what we can do for this is we'll have to we want to get a list of the map entries themselves. So we can do a list of a map entries. And then we specify the entries, and we want them to be integers and integers. All right, and we can name this just a map list, and this will be equal to an array list, or new array list. New array list of map dot entry integers, and we want to go ahead and set the values of the array list equal to our frequency map. Frequency map dot get. We want to get the entry set. So what this line right here does is it goes ahead and inserts every single one of our entries into a list, and that list can then be sorted in the list.sort function in the comparable. So list.sort, we want to do map list. So we're calling our map list and we want to sort it. And sort, I had to learn a lot about, a little bit about lambda. I don't know much about lambdas, but this was a good learning experience, of course. So we learned about lambdas for this problem, and you'll need to learn about the comparable interface and the comparator. Was it functional interface? That is an interface that only has one declared abstract function inside, or abstract method inside. So what this does is it takes a comparator, and a map actually already has entry comparators. Entry dot, I think it's compare by value. So what this does is we can go ahead and see system.out.print line map list. So what this does is map.entry compare by value returns a lambda or a comparator already. Not a lambda. You can put a lambda in here to define the comparator, but it returns a comparator itself for map.entries, which is what we want, and you can specify your own if you'd like to. But I feel like this is a more common solution because you can tell it's written by Java, whoever wrote the JDK. It's map.entry.compare by value is the comparator itself. So what this will get us is if we go ahead and print these out. Well, apparently I can't do that. Okay. So if you're ever stuck, go ahead and look at the JDK. So we'll do the map.entry JDK. So comparing by value, not compare by value. Comparing by value. So what this will do, this will give us the list sorted by the values itself. And you can see the standard out is this is our original frequency map, and it just so happens that the way it hashes, it's in the descending order, so it's highest value first, and this is in ascending order, so it sorted it from one by the integer comparable interface that it implements. It compared each integer value and then puts them in ascending order. You can see this in case 2 as well. So you can get 2 and then 4 and then 4 right here. So that's all well and dandy, but we don't want 2, 4, 4. We want the way it's already sorted. So the way you do that is you do dot reversed. Dot reversed is a method for comparators, okay? And it just reverses the order that is compared. I mean, it's kind of in the name, but I figured out there was an error when I tried to do that, and it's saying there's incompatible types. Comparator entry object v cannot be converted to comparator of super entry integer. And I was kind of stumped by this for a minute, but compared by value, the function itself takes the values k and v and infers them from the map list themselves. But sometimes you have to specify it when you're doing more complex stuff like the dot reverse. So if you do integer, it goes ahead and specifies the ordering of the map entry, so it will be able to sort them correctly. And as you can see, after sorting, it is complete in the order. I know this is not really a good example because they're already in order both ways, as you can see here. Like, they look exactly the same, but if our frequencies were different, like if one had a frequency of 2 and then 2 had a frequency of like 4, then 4 would come ahead of the 1, if that makes sense. So now that we have our map list sorted, what we want to do is we want to go ahead and get the top 2 or k values. So we can do int for int I is equal to 0, I is less than k. And we want to create an int array called, we'll call it solution, because it's what we are returning. And then we want to make a new int array of size k. So for 0 to 1, we want to get the map list. So map list dot index. Let's go ahead and look at the list interface. So list interface. And from here we can see all the methods we can call. So contains equals get index. Okay, so just get. Map list dot get index I. And our map list stores map dot entries. So we want to do map dot entry of integers. And we can just call it ME for map entry. So the map list will return the index valued I item, and it will return a map entry of integer, and we can store that in, well, let's just go ahead and map entry. And what we want to do is we want to store that value into the int of k, or int of I, not int I, solution of I. And we want to store the key inside of that. So we can do solution I is equal to map, or map entry dot get key. And then that should be the solution complete, and we can return our solution array. Oh. Once again, having simple syntax errors. There we go. So these accepted for all three. We can go ahead and submit, delete this, and we can submit our solution. There you go. It's accepted. It has a 19 millisecond runtime. A little bit slower, but I'm pretty sure it's under the nlogn time constraint, or it wouldn't accept it. I'm not for sure. I'm pretty sure. And I thought this solution was very clever. Came up with this on my own. The only thing I didn't come up with is I wanted to put it in a map, and then I wanted to sort the map entries. List.map. I had to figure out how to actually sort a map by their entries. And the way you do that is to insert the map into a list so it can be sorted by map entry, or each of the map entries can be sorted in the list. Because maps usually don't preserve their insertion, they don't preserve their order, but lists do, so you can sort the list. So map.list.sort, and then you want to go ahead and give it a comparator. That's what sort takes in, a comparator. And if it doesn't take in a comparator, it goes ahead and sorts it by its natural ordering, whatever that may be. For any object in the list, if you supply your class or object with the comparable interface, then it will sort by that defined compare to function or method. And so we can go ahead and check the solutions tab. There's C++, we're looking for Java, there's Go, Java, okay. Intuition, approach, complexity. So they also did a hash map, or a map as we did. Count the frequency of each element. I.put, I.get, get or default. I'm not really sure what that function does, but it looks like it's doing the same thing. They put each element into the array, and then they increment it by the +1 if it's equal to the I. Okay, and then int r new int k int on the top k frequency elements. int max, int val, find elements of maximum frequency. For int j is the key set. If a dot get j is greater than max, max is equal to a dot get j. AR plus plus is equal to okay, this is an interesting solution. I'm gonna copy and paste this and see what the time complexity is for this. I'll go ahead and submit that. Had an extra semicolon in there. Okay, so this had a slower runtime than ours did. I wonder what made it faster or slower. So another part of programming other than solving the problems is trying to understand why a solution is bad or a solution is good. So as you can see by that submission we just put in, it has 60 milliseconds and ours is 19 milliseconds, a lot faster. I think it's because you're looping n times and then it's looping n times again, while ours loops just n times once. And it loops n times or n is the number of elements in the array. This loops n times k times, so it would be I'm guessing it's probably around like n times k plus n or something like that. But our solution, you can see here on the left, takes the entry loops n of 1 times, and then it checks, it creates the frequency map. That's a O of n time complexity, right? And then the way the sort algorithm works, I'm pretty sure it's I forgot what the sorting algorithm is called, but it's a mix of insertion sort and merge sort. So it uses, and that's an n times log n time complexity. And that's what we wanted, is to get that or under. And then once again, we just loop k times and enter the map entry into the solution set. But anyways, I think that's going to be it for today's video. I'm not sure what kind of problem I'm going to do tomorrow. But if you like the way I did this today, I took a good amount of time to try to understand the problem before I tried to code it and explain it, because I realized that in the last 2 videos, I spent a lot of time just kind of staring off into space and searching up stuff. I still had to search up some syntax errors that I had and function calls that I didn't remember. But this is all getting put into the brain, and we're remembering it little by little. I haven't done... this is what you want to do. You want to look at, if you're using a map.entry, you want to look at all of the methods you can call. And if you're using a LSP on your IDE, then usually you don't even have to check. You can just put dot and it will tell you every single method you can call. And from the names you can tell what it is, and you can click on it for more information. That's what most people do. So you want to know what you're about to use and how many different ones, not how many different ones. You can see in the JDK itself, like the Java doc for this class, it explains every single function call, all the methods for it, and how you can use it. And that's what you want to do anyways. You want to understand the list. You don't want to just go in and use your IDE. You kind of want to understand what your LSP and your IDE, you want to understand what each version does or whatnot. So I think we like the accepted solution better, or the solution we came up with. It does have a better time complexity, which is kind of what you want in LeetCode problems. B. But I'll say this is a successful medium problem. The easy problems, we didn't blow the time constraints out of the water, but we did come up with our own solutions. And then for the medium problem, we had, which you haven't recorded or posted, the medium, what is it, the sorted anagrams, the group anagrams. So we completed this problem, but I didn't record it, and I kind of had my own solution. We can go ahead and take a look at it real quick. Given an array of strings, group all anagrams together into sublists. You may return the input in any order. An anagram is a string that contains the exact same amount of characters as any other string, but the order of the characters can be different. So we solved the anagram problem. I don't know if it's a LeetCode problem. Yeah, valid anagram, and that only compares 2 anagrams. So this anagram problem, you're comparing one anagram with 7 other anagrams, right? So my original solution was to create a list of size strings of maps to each of these, and then we could map each letter to the actual frequency of it, and then we could check the frequencies of all of those against all other maps, and I just feel like that would be so much overhead and the time would be awful. So we took a quick look at the submissions to see what other people were doing, and the solution ended up being that the sorted version of each word is a valid key entry into a map. So you could see that ACT is and cat, if you sort them alphabetically, will both give you ACT. And then like pots, like hat would give you AHD, which is the sorted version. And then you can sort every single word and compare that to the list, and you can see what the anagrams are based on the sorted word alphabetically. I thought that was a fairly clever solution that I personally wouldn't have been able to come up with by myself. But after we came up with that, I was able to come up with the logic myself and put it together. But the top K frequency, I was pretty proud of myself because I was going to put it in a frequency map, and then I wanted to sort the map. That was the only thing I didn't know how to do. We didn't look at the solutions tab for that. And then from there, after we sorted the map, we would know what the top entries would be. And yeah, I'm proud of the runtime. It's not the average. The average is 14. And then we got some crazy people doing 0, 2, 3, 4, 5, 6. I mean, all the lower milliseconds. Bars beats 53%, which is about half the users. So I would beat half the people in a job interview, so it sounds like. Anyways, y'all have a blessed day. I hope y'all have a good one. Y'all stay in school and do well. If you have any questions, go ahead and leave them down below. If you have any suggestions for what you would like to see next, you can go ahead and put it down below. I've been thinking about doing kind of like a schoolwork video, kind of explaining what I'm doing in school. But I just feel like this would be good for teaching people, being a mentor, and being able to explain what I'm doing, like code-wise for interview portions. I feel like this puts the best of both worlds because LeetCode is used to prepare people for interview questions and interview coding problems. And then in turn, if I'm explaining it on video, I'll be able to get more practice in kind of talking about my thought process and what we're doing in the middle of the coding. Anyways, I will see y'all tomorrow for the next video. Hope y'all enjoy day 3. And if you have any questions, comments, or concerns, leave them down below. And be sure to like and subscribe.